Dear physics aspirants, right now I have the figure of George Simon Ohm, 1787-1854, German physicist, professor at Munich. Ohm was led to his law by an analogy between the conduction of heat. The electric field is analogous to the temperature gradient, and the electric current is analogous to the heat flow. Right now I am going to discuss 3.5 of the NCERT book plus 2 level physics, and the topic will be current electricity, and subtopic will be drift of electrons and the origin on or resistivity. A remark before, you will see here, you have figure 3.33, and this figure will provide you the information regarding the schematic picture of an electron moving from a point A to another point B through repeated collisions. So collisions is very important for your understanding for the drift of electrons and the origin of resistivity. Here you will see a straight line travel between collisions, full lines. If an electric field is applied as so, when the electrons ends up at point B, days dotted lines you will see here with the lines of main lines. A slight drift in the direction opposite to electric field is visible. You will see here after the collision, the direction opposite to the electric field is visible. Slight drift changes in the position of the electron. A remark before, an electron was suffered collisions with the heavy fixed ions, but after collision it will emerged with the same speed but in random direction. So directions are not same. If we consider all the directions, their average velocity will be 0, since their directions are random. Thus, if the n electrons and the velocity of ith electron I is equal to 1, 2, 3, and at given time v I, then you will see the summation 1 by n, summation n, and t is equal to 1, vi is equal to 0. 3.14. Consider now the situation when an electric field is present. Electrons will be accelerated due to this field by A is equal to minus E electron E by m, and 3.15, where E minus E is the charge and m is the mass of an electron. Consider again the ith electron at the given time t. This electron would have had its last collision sometime before t, and let t I be the same elapsed after its last collision. If v1 was its velocity immediately after the last collisions, then its velocity v1 at time t is here. Equation you will see here. Vi is equal to vi plus electron e and by m tt into t. Ti. 3.16. Since starting with its last collision, it was accelerated. Figure 3.3 with an acceleration given by equation 315. For a time interval t I, the average velocity of the electrons at time t is the average of all v I s. The average of vi is vis v1 s is 0. Equation 314 will provide you the information. You will see here the collisions of an electrons do not occur at regular intervals, so intervals are different but at random times, and we have discussed that directions are different. Let us denote by the tau, the average time between successive collisions. Then at given time some of the electrons would have spanned. Regarding the example 3.2 is here also, and solution is here. With the help of this you can understand the subject matter with easiest way. Next course of action will be the mobility. mobilization. We will meet in the next video with a lot more with the mobility. Equation 3.4 is here, and when we study the George-Simon-Ohm's description, then you will get the RC is equal to 2V by R is equal to 2R. 3.4 that has been required with the discussion of the drift of electrons and the origin of resistivity. We will meet in next session with mobility. Till then, thank you. Thank you very much for the viewing the video. Before going to quit, as we have seen, the conductivity arises from mobility charge carriers. In metals, these mobile charge carriers are electrons. So mobility is very nice topic for understanding of current and electricity. We will meet in next session with lot more. Till then, thank you. Thanks for watching the video. Thank you.